before I forget, Thursday, I have an oncologist appointment in Little Rock, so I will not be here Thursday. I will send a reminder email out later in the week, but I have to go see my oncologist for a checkup. Yeah, it should just be just a checkup. I think it'll go well. But they about every 3 months or so, they like me to come down to Little Rock so they can run some blood work and just check out everything. But everything's looked great so far. When I was there in August, they were like, "Man, your numbers are looking super." So just a checkup. All right, it's 9 o'clock. Let me get us going here. Start out looking in our Google Classroom at what this week holds. So this week we have starting Unit 2. Here's our lesson notes and additional practice problems. That's what I'll be doing here during class is we'll be going through these notes. So as usual, if anyone has a printer, wants to print those out, that's wonderful. You can take notes with me as we go through, or you can just take notes on paper or however you like to do that. But remember, any notes you have, you can use on tests and quizzes. It's always good to have that, and you remember things better when you write them down. And here's our assignment. We have a formative Unit 2, Lessons 1 and 2. It's just one formative, one assignment, but it covers these first 2 lessons that we're going to be looking at here in our notes. So let me pull up the camera here. Fabulous. Get that to where it looks good. All right, let's turn on our lamp there. Give it a little bit more brightness if we can get that. Okay. Okay, let's see. Unit 2, solving quadratics by graphing. That's where we're starting at with there. So here's what our notes have. The main ideas, the solutions to quadratic equations. All right, so the solutions to a quadratic equation are the points at which the function intersects the x-axis. Right, so when we graph it, those points that it crosses the x-axis, the quadratic, the parabola, wherever the parabola crosses the x-axis, are the solutions. All right, the solutions are also referred to as the zeros. It looks like an E. Zeros, the zeros, because that's what the function actually equals 0 when it crosses the x-axis. That's y equals 0. So the zeros. It's also known as the roots. Right, the roots of the equation, or the x-intercepts. Right, the zeros, the roots, or the x-intercepts. So the number of solutions for a quadratic equation. Now we know that there's actually 2, according to the fundamental theorem of algebra, because it's x squared. Right, so we know there's 2 solutions. But are they real solutions? If there's 2 solutions, it'd be when we have a parabola. Looks something like that, right? When you graph it, you get this parabola. It crosses the x-axis twice, which means here's one of our solutions right there, and there's one of our solutions right there. 2 solutions, easy to see when you graph, easy to get the solutions. You may just have 1 solution. Get down and touch that. Right there, 1 solution. Let's say that's x equals -2, or just for example. Actually, in this case, when it's right on there, when you solved it, you would actually get x equals -2 as a solution, and you would also get x equals -2 as a solution. It does have 2 solutions. They're just the same solution. So when you graph it, that's why you only see 1 solution, because it's the same solution twice. And no real solutions. Maybe our parabola goes down this time. Maybe it's a negative quadratic. No solutions, it never touches the x-axis, which means both the solutions are imaginary solutions, are complex solutions. We don't see when we graph anywhere that it touches the x-axis. So no real solutions there. So, all right. So this wants us to solve these by graphing, and it gives us lots of practice problems. Like I said, lots of them. We're not going to do them all. We'll just do one or two here. Let's do one. All right. X squared plus 2x minus 3. So we can find out where the vertex is, the x of the vertex. If we do negative b over 2a, 2 times a, that'll tell us where the middle is, the vertex. That'll help if we do an XY table. Because when we can graph any equation with an XY table. Right? We just choose the x's, substitute them into the equation, and that'll give us the y's that goes with those x's. So negative b over 2a. So b is 2. So negative 2 over 2 times a. Well, the coefficient of a is just 1. So that's a 2. So negative 2 over 2. So negative 1 is the middle. That's the vertex. Right? That's the axis of symmetry. The vertex, we need the y also. If we want the actual vertex, we would substitute that in there and get the y. And we'll do that here in our table. But now that we know negative 1 is the center, so let's go negative 3, negative 2, negative 1, 0, and 1. That just kind of centers our table on our parabola. So let's substitute negative 3 into our equation. Negative 3 squared. So negative 3 times negative 3, that's 9. Plus 2 times negative 3, that's minus 6. And then minus 3. So 9 minus 6 minus 3. Y is 0 when x is negative 3. Okay, how about negative 2? Negative 2 squared is 4. Negative 2 times 2 is negative 4. And then minus 3. So we got 4 minus 4, which is 0, minus 3. So minus 3 is the y when x is negative 2. Negative 1. Negative 1 squared is 1. Negative 1 times 2 is negative 2 minus 3. So 1 minus 2 is negative 1. Minus 3 more minus 4. So that is our vertex, because negative 1 we know is the x coordinate of the vertex. So that's our vertex, which means this graph won't go any lower than that. This is going to be a number bigger than negative 4. Because that is the vertex. That's the turning point. That is the lowest point. That's the minimum for our parabola. 0. Well, 0 plus 0 minus 3. See, it is bigger than negative 4. 1. 1 squared is 1. 1 times 2 is 2 minus 3. 1 plus 2 is 3 minus 3. 0. Okay, so we can graph our equation now. Negative 3, 0. 1, 2, 3. Negative 2, negative 3. 1, 2, 1, 2, 3. Negative 1, negative 4. 0, negative 3. And 1, 0. So there's what our parabola looks like. When you graph these things, when you make this table, you need to go back and connect the points. I know some of you guys have been doing some of this, and you've graphed the points and never connected them. Well, that's not accurate, because this graph exists at x equals a half. At a half, looks like it's about negative 2 is what the y is. But if you don't connect them, you're saying the graph does not exist between 0 and 1, or between negative 1 and 0. But it does, because this is just a quadratic equation. So we could substitute 1/2 in for x, or 0.1 in for x. All those places exist. So we have to connect the graph to show that all of the x's, because this is the domain of this is from negative infinity to infinity. So all the x's exist. So we got to connect that. So make sure when you're graphing it, if it's an equation like this, you should be connecting it, not just disconnected points. All right. So find the solutions by graphing. So what are our solutions? Our solutions are right there, right there. The solutions are -3 and 1. That is our answer. Those are the solutions for this quadratic equation, which means if we substitute those numbers in, it'll equal 0. When substitute -3 in, it'll equal 0. When substitute 1, it equals 0. That's the solution. So graphing, it makes it real easy. You just find out what the x is. Find out what the x is. And we can do that. Let's look at one on this page. And this time, we'll just put it on Desmos. Let's look at -x squared minus 11x minus 28. Let's do that on Desmos. Let's go to Desmos here. All right, y equals -x squared minus 11x minus 28. Now, even though we can do this on Desmos, it's important to know how to do it without Desmos. Sometimes you may need to work on something and you don't have Desmos available or whatever. You need to be able to make an XY table for any of these equations. Okay, so when I look at this, there are two solutions. The solutions are -4 and -7. So that is where it crosses the x-axis. That is the zeros. That is the roots as the solutions to this equation. So I'll write that in -4 and -7. All right, let's move on. That is what 2.1 is solving quadratics by graphing. All right, not overly difficult, but let's look at other ways to solve. Factoring quadratic equations. Factoring using the greatest common factor. Okay, this isn't too bad right here. We can do this. Factoring using the greatest common factor. So if we look at these two terms, is there anything that we can take out of both of them? This has an x, this does not. This has a y, this does not. This has a 6 and an 8. So that does mean that there is a common factor there because we can divide 2 out of both of those. We divide 2 out of 6x, we got 3x. 2 out of 8y, 4y. Okay, so we have factored using the greatest common factor. That's as far as we can go, because in 3x and 4y, there's nothing in common that can be factored out of those. So we factored that expression the smallest we can get. Okay, let's look at this next one. 12x to the third minus 18x squared plus 24x. Well, right away I see that there's an x in every one of them. This has 1x. This has x squared, x to the third. So we can factor an x out. But we can also take a number. That's 12, 18, and 24. The greatest common factor of those is this is 6 times 2, 6 times 3, and 6 times 4. So we can factor a 6 out of all of those. So if we factor 6x out, divide this by 6x, it's going to leave us at 2x squared. 12 divided by 6 is 2. X to the third divided by x is x squared. Okay, now we got minus 18. So we take a 6 out of that. And x squared divided by x. So we got minus 3x. And then 6x divided into 24x. That's it. So we have factored that down to the greatest common factor is a 6x that comes out of there. And now this is what our new equation is. All right, there's 2 more I'll leave that you could try. I want to move down to factoring using differences of squares. Difference of squares. Now there's some key words in here. First one I want to do is difference. Because this situation can be done, you can factor this a number of ways, but if you can recognize that this is the difference of 2 squares, then you can take a shortcut. So it's all about recognizing it. What is difference? If we're taking the difference of something in mathematics, that means something specifically. The difference is when you subtract something. When I want to find the difference, what's the difference between 2 and 7? Well, it's 5, because we just take 7 minus 2, and that's the difference. Difference means that we subtracted. It's a very specific mathematical term, difference. So we have to see that there is a subtraction for there to be a difference. The other thing we need to look for is 2. There's only 2 terms. There's just 2 terms. These up here, we can't even consider it being difference of 2 squares, because these have more than 2 terms. And this one adds, so that's not going to be, so none of these would be a difference of 2 squares, because this one adds, and these all have more than 2 terms. So we know it would not qualify for this special shortcut. So the last term we have is the squares, right? Squares. What's a square? When something is squared, that means it's been multiplied by itself. Something times itself is a squared total. So if we can look at this, first we see that's a difference, and then we see there's 2 terms. All we have to determine is, are these both squares? Was there something multiplied by itself to get this? Was there something multiplied by itself to get this? Well, x times x is x squared. So this is a square. 3 times 3 is 9, so that's a square. So right away we know that we have the difference of 2 squares, and there's a shortcut. So we can factor this real easy. What is the first term? X squared. So what are the 2 same things that were multiplied? X and x. Has to be x and x. Has to be the same thing. This has to be 3 and 3. So one of them we make positive. One of those we make negative. X plus 3 times x minus 3 will be x squared minus 9. The shortcut, you just take the square root of the first term and the square root of the second term, make one positive, one negative, and the difference of 2 squares, when you factor that, quick and easy. We can check that, because if we multiply it back together, x, we've got to distribute, right? Distribute the x times the x is the x squared. X times negative 3 is negative 3x. 3 times x is plus 3x. 3 times negative 3 is negative 9. So you see what happens here is you have negative 3x plus 3x. Those cancel each other out. You end up with just x squared minus 9, which is what we started with. So difference of 2 squares, it's some of the easiest factoring to do is just take the square roots of those numbers. All right, so this one. This is the difference of 2 squares. X times x. Anyone know the square root of 225? What number multiplies by itself to get 225? We know y the fourth is y squared times y squared. Put the y squared there. But we need to know 225. 15. Good job, Glenna. So we got plus and minus. X plus 15y squared, x minus 15y squared. And that is how you factor that out. Quick and easy. All right, I want to look at this. Factor using multiple methods. Multiple methods. Let's say, okay, so what is this talking about? 3x squared minus 27. Well, the only thing you see that you could factor out of that is it does have a greatest common factor, like we did at the top. A 3. So we can factor out 3, and that leaves us with x squared, and then 3 divided that is minus 9. Well, now we've got difference of 2 squares. So we're not finished with this yet. Because we know that this factors down to this. X plus 3, x minus 3. Now we're finished with that. This took 2 steps. This over here also, let's see. This is the difference of 2 squares, right? Because T squared times T squared is T to the fourth. S squared times S squared is S to the fourth. It's the difference. There's only two terms. So we know we can say T squared plus S squared and T squared minus S squared will be the difference of two squares. I might look at that and say, okay, we're done with that one, but we're not, because look, this is the difference of two squares. So it factors further. So we got T squared plus S squared. That will not factor further. That's not the difference. That's the sum of two squares. But this will factor down to T plus S, T minus S. Now it cannot be factored any further. So we got to pay attention to those things. All right, so factoring using greatest common factor is not bad. Difference of two squares, that's a nice shortcut to just take the square roots of those. Now let's look at, let's see, there's some more practice on here. So you can practice these. This is in your notes. Factoring multiple methods and more practice there. I want to get to this one. Factoring quadratic expressions in the form of ax squared plus bx plus c. All right, so this has got an example problem down here. And it says always check for greatest common factor before you start, because maybe you can simplify this by pulling out a greatest common factor. And then we got to say what two numbers multiplied together give you C and added together give you B. So when we're factoring it, we need a number that multiplies to C and adds to B. Find the factors of C and add them together until you get the value of B. So I'm gonna skip to where the problems are, because we got grouping over here. Here we go. All right. Let's look at a sample problem. So if we're going to factor this, we're going to factor it in the two binomials. And we know it's going to start with an x, because the first thing we have is x times x, which is x squared. Excuse me. But now we need to get 36. So what you need to think about, and I'll put it, a lot of people like this method. What would multiply together? This would be multiply up here. And this down here would be add. What two numbers could I put here that would multiply together to equal 36, but would add to be negative 13? So let's look at what all numbers equal 36. 1 times 36, all right? 2 times 18, 3 times 12, 4 times 9, and 6 times 6. All of those numbers we could multiply together to get 36. But only one could we add together, because you've got to remember, if we're getting 36, this could be -1 times negative 36, -2 times negative 18, because a negative times a negative is going to give us a positive. I just need to know what numbers there are. But if I need them to add together to be negative 13, there's only one set of numbers we could use. -4, -9. 4 and 9, these add up to be 13. If I make them both negatives, they'll add up to be negative 13, and they will multiply together to be a positive 36. So this factors to x minus 4, x minus 9. And that is the two factors that we can multiply back together to get this original quadratic. Okay? Let's try another one. So one right beneath it here. We know x times x. Now we need to know what times what would be 12. So -12, pardon me. So -12 is what it needs to multiply. -4 is what it needs to add to. So 1 and 12, 2 and 6, 3 and 4. That's it. It's our only choices. Nothing else would multiply together to be 12. So if I need it to be -4, this is a -12. So one's going to be negative, one's positive. Here's a little hint. If the middle term's a negative, when I have a -12, that means the bigger number is going to be the negative number. So in this case, 2 and 6, if 6 is the negative number, would add up to be -4. So x plus 2, x minus 6. The bigger number is going to be whatever sign this is, because we need it to end up being negative when we add them together. So the bigger number has to be negative for that to work. All right. Let's move on to here. What happens when a is greater than 1? Oh, that's a good question. What happens when a is greater than 1? All right, let's look at this first one right here. Now we have a little different situation. I sent you the key for that. Well, we're not going to be able to break it to two binomials yet. 3 times 81. We need to multiply these together and figure out what's the factors of those. Okay, factors of those. So let me get rid of this. I don't know how much room we're going to need. All right. So 3 times 81 is 243. Wow. So how many different ways can we get 243? Well, 1 and 243, of course. 3 and 81. All right. We may need a calculator up to make sure we don't miss anything here. So let's pull a calculator up and do some ciphering. So 243. Let's see. We know it's not going to divide by any even number. It's not going to divide by 5. Let's see. Will it divide by 7? Oops, I didn't do it right. 243 divided by 7. Nope. How about 9? 243 divided by 9. Yes, 9 times 27. Okay. Let's see if there's anything else. 243 divided by, again, it's not going to be an even number, so let's try the next odd number. 11. Nope. 243 divided by 13. Nope. 243 divided by 15. It's a good way. If you don't know right off, try those. And let's see. Once we get to 27, we know we're done. Let's try 243 divided by 17. Oh, I didn't get the 17. 243 divided by 17. No, I don't think there's going to be any more. 243 divided by 19. I think we fit all the combinations. Yep. 243 divided by 21. Not going to work. 243 divided by 23 is not going to work. Okay. I think we've hit all the combinations. There's only 3 different ways you can get 243. 1 times 243, 3 times 81, 9 times 27. Which one of those would add up to be 36? We've got it right there. Okay. So what we have to do when we have a number out here that's bigger than 1 is we're going to take 3x squared and we're going to break up this negative 36 into 2 terms. We're going to say, okay, that's the same as negative 9x and negative 27x plus 81. So all we did was took the negative 36x and we broke it up and made it 2 pieces. That equaled the original number. Negative 36 equals negative 9 plus negative 27. Combine those, we're right back there. So we haven't changed the equation. We've just rewritten it in a new form. Now is what they call grouping, factoring by grouping. All right, so we're going to group these. We're going to take those terms right there. Now, when you group these, we could put the 9x and the 27x on either side, whichever ones it naturally goes with, right? Now, these, it doesn't matter because both of them work with 3 and 81. It would matter on something like this where we have a 5 and a 6, and we'll look at that one next. So now we want to look at the greatest common factor again. Greatest common factor. 3x squared and negative 9x. We can pull a 3x out of that. So if we divide 3x out of that, that just leaves x. And we pull 3x out of that, that means minus 3. Okay? We just factored this down, pulled the greatest common factor. How about here? 27 times 3 is 81. So we can pull a 3 out of here also. So what that leaves when we pull a 3 out, and it's a positive 3. We pull a positive 3. If we pull 3 out of that, that leaves, I'm sorry, not 3. I did the wrong number. You shouldn't do this with a pen because I can't erase, right? I pulled a 27 out. That's what I pulled. If I factor 27 out of that, all it leaves is an x, and I pull 27 out of that, that just leaves a 3. I'll tell you what, let's pull a negative 27 out of that. We're going to pull a negative 27 out, and that'll make that a negative 3. Because I need these to match. I need these to match. If I pull negative 27 out of that, that just leaves x. If I pull negative 27 out of that, that leaves negative 3. So now what we have is we have 4 things being multiplied together. 3x times x minus 3 times negative 27 times x minus 3. Which means if I pull the greatest common factor out of here, 3x times x minus 3, I can factor an x minus 3 out. What's left? 3x. And over here, I've got minus 27 times x minus 3. If I factor the x minus 3 out, what's left is the minus 27. So it turns out this is the factors of this. Now, we could actually factor a 3 out of that as well. So we could go one step further and say it's 3 times x minus 3 times x minus 9. Because we factor 3 out of that and put it out there. So this is what this factors down to. Now, grouping takes more practice than the others. Let's try another one over here. 6 times 5 is 30. So that'd be 1 times 30. It'd be 2 times 15. It'd be 3 times 10. It'd be 5 times 6. And that's it. There's no other ways we can get 30. 1 times 30, 2 times 15, 3 times 10, 5 times 6. So which of those adds up to 31? Well, the first one. The first one. All right, so we're going to say this would be 6x squared. And now we need to do either plus 1x or plus 30x. Because over here, we're going to have the plus 5. All right, so we can put the 30 with the 6. Let's do that this time. And plus the 1x plus 5. So we just took the 31x and we made it a 30x and a 1x. So now we can factor out greatest common factors of grouping, right? We're going to group those together. What can we factor out? It's like 6x. 6x out of that leaves just x. 6x out of 30 equals 5. And what do we have over here? X plus 5. That's all we have is x plus 5. Plus x plus 5. We got this plus x plus 5. So we have this factor. We can factor out of both of those. X plus 5. We factored out of here, it leaves 6x. We factored out of plus. It's just plus 1. Because we pulled the x plus 5 out of there. X plus 5 divided by x plus 5 equals 1. X plus 5, 6x plus 1 is the factors when a is greater than 1. Again, that takes some practice. I've posted a video on Google Classroom just about this because it is a little trickier with the grouping. We have more practice problems over here. Like I say, I'll give you plenty of practice problems in the notes, so you can practice all you need to. These are all where the a equals 1. So that would just be this style, right? This style here. And then there's also several practice problems over here. When a is greater than 1, you got 2x squared, you got 6x squared, you got 4x squared. So there's plenty of those you can practice as well. And then here's just some additional practice at the end. Greatest common factor practicing, factoring with just where it's a 1. When factoring, always look for a greatest common factor first.
Yeah, that first thing was
Greatest common factor. Because it could say like on this one, before you started, you want to factor out a 5. Now this is just a regular one like this to factor, because it just be z squared minus 5z plus 6. And then some more practice and trinomials with that. So again, difference of squares practicing, have some more of those problems. And that is it. So we're all into quadratics now. We're looking at factoring quadratics. We're looking at solving quadratics by graphing to get the solutions. But you need to be able to do it in all the different methodologies to be able to do that there. So, whew, a lot of stuff thrown at you today. That's how this Algebra 2 class is. We got a lot of stuff thrown at us in Algebra 2. So, all right, it's November. It means if you're behind, it's time to start kicking it in gear, because you're going to run out of time. We're going to be into December before you realize it, because we're going to take a week off this month, right? We got 3 weeks and then the break, and you'll have a whole week where we won't have any school. So we get caught up soon so you can enjoy that week if you're behind. So if anyone's got questions, hang around. Otherwise, I'll let you go. I will be in Little Rock on Thursday, just as a reminder. I said at the beginning of class, but I have an oncologist appointment. We will see you guys later. Email me if you need help. Thank you.